reduction, oxidation reaction. They always come together. Just to a quick remind, if you lost electrons, you undergo oxidation, you can serve as reducing agent, which the things always happen in the anode if you have a electrochemical cell. Okay, so LORA means actually the oxidation reaction. GROC means actually the reduction reaction, just a refresh of your memory. So we're going to use LORA and GROC here too. Assuming today you see this reaction, A plus B, they give you A plus and B minus. You want to identify who is actually LORA, who is actually GROC. In order to make those judgments, the first thing you do is actually you write out the oxidation number of the species. What is the oxidation number of A? 0, right? How about B? Good. How about A plus? Plus 1. B minus? Negative 1. You know A goes from A become A plus. So the oxidation number goes from 0 to 1. So it's undergo oxidation. Therefore, this is actually your LORA. It lost electrons, got oxidized, can serve as reducing agent, and this reaction will always happen at the anode. Okay, so let's see your LORA. A is undergo LORA, right? That means actually your B is going to be your GROC. So you gain electrons, right? That's why you go from 1 to negative 1. You undergo a reduction reaction. So once you can see these things, you can start to break down your chemical equation to so-called the half reaction. So this is actually a very important step that you need to do it by yourself. So you need to know that the A is going to become A plus and it's going to lose electron, right? And then your B is actually gain electrons, therefore it becomes B minus. So later on when we do these balancing equations, this will become a critically important step. But before we do that, okay, I want to actually give you some more practice here so you can actually identify who is undergo LORA, who is undergo GROC. So let's look at this. 2 potassium plus chlorine become 2 KCl. What is the oxidation number of this? 0, right? Because it's at its natural existing states. How about Cl2? 0. How about this? KCl. KCl overall is 0, right? But right now you want to actually start to break down the things to see the oxidation number of each individual atoms now. So remember potassium, if you look at the periodic table, it's what? 1A group. If you see a compound, you have a 1A group. It's always +1, always. And then because overall is neutral, it's 0, right? That means actually your chloride has to be -1. So now if you just write down the oxidation number of your potassium, you can see it goes from 0 to +1. And if you do the same thing for your chloride, it goes from 0 to -1. Okay, so who is LORA? Potassium, right? So you see the increase of oxidation number, that means actually you undergo oxidation, right? So you lost electrons, that's actually your LORA. And then chloride will be your GROC. So let's first example. Let's look at another example. Okay, this looks actually quite complicated, right? How should you see this? Okay, you want to see how many different atoms you have here. So what other atoms you have seen here? You have carbon, you have hydrogen, you have oxygen, right? You actually only have 3 types, different atoms. Then you want to know before and after reaction, how the oxidation number of these atoms changes. So from there, you can figure out who is actually your LORA, who is actually your GROC. Neutral species, right? CH4. And here you should use the rule that the proton, the H always carries +1. So you know here your H is +1. That means your C will be -4. You need to do this calculation very fast now. So you know your C is -4, H is actually +1. How about this? What's the oxidation number of your O? 0, right? How about your CO2? So it's a compound, right? It's not just O2, okay? It's CO2. That means your C is going to carry -2. How about your C? +4, right? Okay, move on to the next one. O will be -2, H will be +1. Okay, let's analyze the oxidation numbers before and after reaction. Let's look at C. Original your C is -. What is the oxidation number after the reaction? +4, right? So it lost a lot of electrons, right? The oxidation number goes up from -4 to +4, right? Therefore, you know it's undergo a oxidation reaction, right? And that's actually your LORA. Now let's look at your proton. Before reaction, what is the oxidation number of your H? +1, right? How about after reaction? It's +1 too, right? So what does this tell you? It did not actually undergo any redox reaction. This is actually not going any redox reaction. How about your oxygen? Before reaction, it is what? 0, right? How about after reaction? -2, right? So it's actually gaining electron, right? So it's actually your GROC. Let's look at another example. First step is actually figure out how many different of atoms you have. Here you're going to have silicon, chloride, hydrogen, and oxygen. So those are the 4 different atoms you are going to have. So then we need to actually figure out the oxidation number of each atoms now. Cl in a compound always carries -1, right? How about your silicon, Si? +4, good, okay. H2O, you know the O is always -2, H is always +1. HCl, H will be +1, Cl will be -1. SiO2, you know your O is -2, right? Your Si will be +4. Let's start from silicon. Before reaction is +4, right? After reaction, still +4. Right? So it's not your LORA, it's not your GROC. How about your Cl? Cl go from -1 to still -1, right? So it's not. How about your H? +1 to still +1, right? So it is not redox reaction, right? How about your oxygen? -2 to -2. It's not, right? So what does this tell you is actually that by analyzing your oxidation number, you realize this is not a redox reaction. So this is how you actually differentiate whether you have redox reaction or not. If you have a redox reaction, you must have your LORA, you must have your GROC.